Hello, ladies and gentlemen, and thank you for joining me once again. We're continuing our look at the 2009 Grade 8 Gauss contest, and we're on question 23. In the diagram, the circle is inscribed in the square. This means that the circle and the square share points S, T, U, and V. And the width of the square is exactly equal to the diameter of the circle. Rounded to the nearest tenth, what percentage of the line segment XY is outside the circle? So they're talking about these parts here. Okay. So can we figure out the total length XY? And then if we can do that, can we also figure out from there what the length of these outside parts is? Is there a way to figure out these lengths? And it's not going to be easy to calculate them directly, so what we might want to do is use the circle here that helps create them. So let's explore a little bit of the geometry. Now, I don't believe that they... You know what? I should have drawn the circle first. It's hard to fit a circle inside something. It's hard enough to draw a circle as is. Let's not make challenges even harder for ourselves. So there's a circle. There we go. And slowly draw a square around it. Things you'll learn after you make a couple hundred math videos online. Okay. So X and Y. Fine. Alright, so we need to connect up X and Y. And you'll notice it passes right through the circle. In fact, there's a nice little symmetry here. If you imagine this was a piece of paper, you could fold from one side to the other, and the circle would fold right on itself. And from there, you can actually figure out that this length here is a diameter. It certainly looks like one, but it's important to be able to think our way through these things and realize, yeah, that probably should be a diameter. It's sort of the widest point of the circle. Okay? If it weren't, if it were something shorter, which we call a chord, then when I fold it along the line XY, it wouldn't match up with itself. But it does. Okay. Not a lot of people out there, certainly not a lot of grade 8 students worry about these sort of things. To them, it's obvious this is a diameter. Sometimes I run into problems when I do these because I'm used to higher level contests, you know, grade 12, grade 11, where they actually make you prove things before you're allowed to just do calculations. Anyway, we want these purple parts. Now we can see that the purple parts are the total length of XY minus the diameter of the circle. Okay. Now, I don't believe that they gave us the... No, there's no lengths here. But we don't actually need lengths to do this. Okay, it'd be nice. But we don't need lengths because what's going to happen is they're all going to cancel out when we make our percentage calculation. Okay. So equals the lengths outside a circle. So we want to figure that out, divide that by the total length xy, and multiply by 100% to turn it into a percentage. Okay, well, what are we to do? We don't have any actual numbers to work with. Well, we invent one. Let's just call the length of the square, or the side length of the square S. You might say, well, why don't we make another one for, say, radius of the circle or diameter of the circle? And that's, you know, that's an admirable thing to want to do. We want to use that length at some point, so why don't we give it a name? And this is a problem that you can sort of run into anywhere in math. Introducing too many variables. So what I suggest, if you know you're prone to that sort of a problem, is you introduce one variable, see how much that clears up, and then whatever's left over, you introduce another variable for that, and see what gives you that, what that can help you calculate, and so on. Because if we just say, you know, here's S, and we call maybe the radius R, and we don't ever form a connection between the two or anything like that, we're just going to have a lot of formulas with a lot of S's and R's, and it can just be a disaster. Okay? So we're just going to start with this S and see, could we maybe talk about the diameter with S? If not, then yeah, the diameter deserves its own variable. But don't be too hasty to just, you know, introduce this variable, this variable, this variable, this variable, because you may find that you just have a lot of letters, and they aren't really connecting in any way. and that doesn't lend itself to calculations or simplifications or anything like that. So it's something to watch out for. So if that's s, well, this side here is s, and we've got a right angle here, so xy squared should be s squared plus s squared. The Pythagorean theorem, we got a right angle triangle here. So this would be 2s squared, square root both sides, xy, which I'll remind you is a length we'd like to know, is square root 2 of s. Okay, now how about that diameter? Well, what did they say in the question? That the width of the square is exactly the diameter of the circle. Let's clean that up a little bit. But the width of the square, so the side length of the square is exactly the diameter of the circle. So this diameter here is actually s. So there's s, there's s, there's s. So these extra bits outside, the lengths outside the circle, we'll call them outer lengths, are root 2s minus s. We'll take out a factor of s. We'll have root 2 minus 1. Now we want that as a percentage of the total length of xy. Right? Length of xy. Percentage of the length segment xy is outside the circle. So 100% times the outer lengths over the whole length xy. So this is 100% and s root 2 minus 1 over root 2s. And here the s's are going to cancel out. So we didn't actually need to know the side length. It just, maybe it helped us make a formula or two. All right, so we want 100% times square root 2 minus 1 over square root 2. Not a problem, so we can just grab our calculator. Square root 2 minus 1, it's about 0.41, divided by the square root of 2. So that's 0.2928 something or other. So we multiply that by 100%, and what are we getting? We are getting about 29.28%. Now I think they wanted us to round it, right? To the nearest tenth. Okay. So we round this up, 29.3%. And I think I saw that that was A. Yes, indeed it is A. So there we go. That's question number 23. A nice little geometry-based question. I really like it. We've got 2 more questions to go, and I would once again encourage you, if you haven't tried them already, to please stop watching and try the questions for yourself. It's so much more important to practice things by putting actual pen to paper than just sort of thinking through things in your head or watching my videos saying, yep, I would have gotten that. Oh, yeah, that formula. Yeah, I know that formula from class or something like that. Actually try them out and see how good you can actually do these things. Or see how well you can actually do these things. All right, well, question 23 has been a pleasure. I will see you guys for question number 24 in the next video. Thanks for watching, and I'll see you next time.